Hello, welcome to Darth Dragon Does Math. Today we're learning about composite figures, area of composite figures. Alright, so what a composite figure is a it's a figure. Get that. It's a figure, or I'm going to say a polygon. It is a polygon that is made up of two or more polygons. Now, that sounds, maybe trivial, but really what you'll find is that literally any shape at all, except for maybe a circle, could be made into a composite figure. It's just it depends on how you personally strike the lines through it. So here's what I mean. So number one, divide each figure into two right triangles and a rectangle. So the way we do this is I get my handy dandy double rulers out, and I'm going to draw two lines. One of them, so I put that on the base, one of them coming from one corner up and the other one coming down from the other corner. And what you notice is I have two right triangles and a rectangle in between. And why that's important is because we can switch up the way we find the area of these shapes. Depending on what information is given, this becomes very helpful. So there's two ways I can find the area of this shape. One way is the standard way. Area is equal to base times the height of the parallelogram. Or you could find the area of the rectangle plus the area of the two triangles. So there's two different ways to do that. Area of the rectangle plus the area of both triangles, or base times height. And I know you're saying, well, this looks more complicated, but it just really depends on what's given to you. Sometimes you're not given what the height is, and you're only given like a piece of the base down here, and you'll see examples of that. But so this is an important skill to have. This trapezoid, I like making my base to the bottom, so I'm going to flip it just a little bit. And so I'm going to make two lines from both of these points down. And again, I've made two right triangles and a rectangle. So this area could be 1/2 base 1 plus base 2 times the height, which was the area of the trapezoid. Or it could be the one rectangle plus the two triangles. And I'm not writing all that, like the actual formula there, but we know base times height, and that's 1/2 base times height, and we just kind of add it all together piece by piece. And either way is fine. If we're going to do this one, divide the figure into a rectangle and a triangle, I can do that. I'll draw one line right there. So I have a right triangle here and a rectangle there, and that might be a square, but at the very least we know it's a rectangle. So one way to find the area of this one would be, again, the trapezoid, 1/2 base 1 plus base 2 times the height, or one rectangle plus one triangle. Either way will work, and it just depends on which how you go about it. This is number 3 here. This time I want to divide it into 3 triangles, so I can do one triangle, the one I made and the one before, But the other triangle, I'm going to find by splitting this in half. And you'll notice that it is 3 triangles, but more importantly, it's 3 right triangles, which right triangles are far easier to work with than things that are scalene or acute or obtuse angles. So scalene doesn't necessarily mean it can't be right. Okay, describe 2 ways to find the area. One is, of course, the area of the trapezoid, or the area of 3 triangles added together. Either way will work. They're both just as they'll both work in certain situations, and not one is necessarily better than the other. So, and again, we'll get to that in a minute. I just want to show you how I can break them up. And then now these 2 at the bottom. Draw 1 line to divide shapes that we don't know how to find the area of into 2 shapes that we do know how to find the area of. Alright, and this is where learning how to pull apart composite figures really helps us understand how to find the area of any shape we come across. So the first one is I want to draw 1 line, and some people say draw a line right down the middle, but that's not going to work. The only one that will work is right there. So now I have a trapezoid and a rectangle. A trapezoid and a rectangle. So I would find, to describe a way to find the area, you would find the area of the trapezoid plus the area of this rectangle. Combine them, you can find the area of this whole shape, which looks like maybe a house or a baseball home plate. Draw 1 line. See, I had a student say, "I'll just draw a line straight down the middle." And the reason you can't do that is, well, those are trapezoids, but they're not. And they're not trapezoids because no lines are parallel. So the 1 line has to be from here to here. So now I have a triangle and a trapezoid. Now I've had, you could always break it up some more. You could put a line there and a line there and make it a rectangle plus 2 triangles, but we only wanted to do it with 1 line. So that's kind of breaking up shapes. So let's do some math with it. So I have this. I say trapezoid ABDE is made up of a square and a triangle. So this is a square and this is a triangle. And that's important, especially the fact that that's a square, because that'll come into play in a minute. The area of the square is 64 centimeters squared. And the length of CD is 11. That's given to us. Find the area of ECD. So I'm going to put some marks around ECD so that it's clear what we're doing. We're finding the area of that triangle right there. That's the area we need to find, ECD. So I have the base of this triangle, but I don't know the height yet. So I'm going to have to figure that out based on what I know about this square right here. So the area of a square is equal to base times height, but really a lot of times we just say base times base or height times height. It's the same number because it's a square, all sides are equal. So really the area of a square, 64, is equal to base squared, Whatever this side is, it's that side. So what number multiplied by itself is equal to 64? We can take the square root of both sides, and we'll get 8 is equal to the base. So this side is 8, this side is 8, this side is 8, and that side is 8, which that side happens to be our height of the triangle. So the area of the triangle, so triangle ECD, is equal to 1/2 base times the height, which is 8, sorry. And that's the first bell, so it's going to ring again here in a minute. So 1/2 times 8, so we're going to do 11. 1/2 times 8 is 4. 11 times 4 is 44, and it's 44 centimeters squared because it's area. So again, the way I did that, you start with the area of the square, is 64. That means each side is 8 because 8 times 8 is 64. And then you have the height of the triangle. 8 times 11 is 88, divided by 2 would be 44. Alright, this one's a lot harder, a lot more difficult, just because it has more steps, and more steps seem to confuse people. More chances. More chances to trip up. So let's go through it slowly. We have trapezoid PQTU. PQTU, that's the whole thing, is made up of a parallelogram right here, a triangle, and a square. The area of trapezoid PQSV, so I think this is the first part that trips people up. PQSV, it's not asking about the whole thing, it's asking about the small one, is 99. So I'm going to put a big circle in the middle of this. That is 99 inches squared. Find the area of trapezoid PQTU, the whole thing. So we know that part, we want to find the whole. So the first thing I need to do is I need to fill in my blanks. Rarely am I ever concerned about diagonal sides, so I'm going to ignore that. So let's do this one. I want to know what this side is right there. Which we can tell without doing much math at all. It's just knowing what shape this is. What is this shape right here? PQRV. PQRV is a parallelogram. That means that opposite sides are equal. So if this is 8, QR, if PV is 8, QR is also 8. So we filled in one of our blanks. But we don't know what the height is. We don't know the height. So let's find it out. Let's figure it out. We know that the whole thing is 99. And it's a trapezoid. So 99, we're going to use the area formula of a trapezoid. Area is equal to 1/2 base 1 plus base 2 times the height. So area is equal to 99. Base 1 is equal to 8. Base 2 is equal to QS, so this whole thing, 8 plus 6, so that's equal to 14. So area is equal to 1/2 base 1, 8 plus base 2, 14, times the height. That's equal to 1/2, 8 plus 14 is 22, times the height. 1/2 of 22 is 11, so 99 is equal to 11 times a number h, so 11 times something is 99. I'm sure you already figured it out, but the answer, the height is equal to 9. 99 divided by 11 is 9. So 9 inches. So this whole thing is 9 inches. And if you remember from the question, VUTS is a square. It's a square, so that means that's 9, that's 9, that's 9, and that's 9. So I'm going to show you two different ways to solve for this area. The first way is the trapezoid, right? So you can say, well, the area is equal to 1/2 base 1 plus base 2 times the height. And we know that so area, we're figuring that out. 1/2 base 1 is the whole top. 8 plus 9, that's 17. Plus the whole bottom. 8 plus 6 is 14. Plus 9 is 23. Times the height, which is 9. So this is equal to 1/2 times 17 plus 23 is 40 times 9, which is equal to 20 times 9, which is 180 inches squared, which isn't too difficult to do, but I have an easier way. We already know this is 99, so we just need to know what this square is. The side lengths are 9, so the whole area of the square is 9 times 9, which is 81 inches squared. So the area of the whole thing is this little trapezoid, 99, plus this square, 81. 99 plus 81. Well, 99 plus 1 is 100, plus 80 is 180 inches squared. And I don't know about you, but I don't think this was super difficult, but it's a lot easier just to write that. So that's all for composite figures. I hope that was helpful. All right. Math!